What we're talking about today is finding the distance between 2 points. Okay, so I'll tell you what. Let's do this, and we're going to learn a formula, but we're going to work our way up to that formula, and we're going to call it the distance formula. Now, I could just sit here and just show you what the distance formula is, but I don't think that's a good way to do it. I think it's a good way to kind of work you up to it so you see what's going on. So we're going to take it slow. We're going to work our way up to the distance formula, and this is something that you will have to have memorized. All right, but let's start with this. Got a little line segment right here. Let's pretend that this little line segment represents maybe going on a trip or something, okay? So let's say it's a mile marker. Go down the highway, you'll see that a lot on highways. Every mile you'll see a mile marker. Even some highways, like every 1/10 of a mile, they'll tell you how far you are, okay? And those actually come in handy because let's say you're on this big, long highway. Let's say you're going down 95 and there's really nothing around. There's no towns around or anything, but let's say you break down, okay? And you got to call somebody and say, hey, broke down, can you come get me? And they're going to say, well, where are you? I'm like, I don't know where I am. I'm between a couple cities and I'm like in the middle of nowhere here. But you look around, and there's mile markers, especially if there's 1/10 of a mile markers. And you can tell the guy, oh, I'm on I-95 going south. I'm at mile marker 213. You may not have any idea what city you're near or anything else, but those are always good. So you could see mile markers on the roads. Not every highway has them, but most of them do, especially the major ones. But let's say, we'll make it easy. Make these numbers as easy as possible. Say you're cruising down the road and you're at the 20-mile mark. Then you see a big old billboard for McDonald's or Burger King or Cracker Barrel or something like that. That's always a good restaurant to eat at if you're on the road. And never been to Cracker Barrel? You got to go to Cracker Barrel. It's good food at Cracker Barrel. So anyway, let's say you're at the 20-mile marker and it says Cracker Barrel is at the 50-mile marker. Sometimes they'll say it's exit 50 because a lot of these highways have their exit numbers according to the mile markers. So if it's at mile 50, they'll call it exit 50, that kind of thing, all right? So this is very simple. It's not meant to trick you or anything. I'm not asking you a trick question here. If you are at mile marker 20, and you need to go to mile marker 50 to eat a Cracker Barrel, how many miles do you still have to go? You got to go 70 miles if you're at mile marker 20? No. You don't add them. What do you do? So what'd you do, Joe, to get that? Joe, what did you do to get 30? Come on, it's not a trick question. Just answer. Joe, what'd you do? Come on. What math did you do to get 30?
I don't know. I just
subtracted it.
Yeah.
Yes, you subtracted it. Okay. So it's 50 minus 20 is 30. Now watch this. Okay, it's over. Don't worry about it. You could have gone the bigger one minus the smaller one, but watch this. You could also do this. If you wanted to, you could go the smaller one minus the bigger one. We don't normally do that because what do we get for our answer? Michael, what'd you say? You get a negative, right? It would be negative 30, but watch this. When you're talking about distances, you don't really care what direction you're going, all right? So in Algebra 1, you learn to think about how far away something is from 0. That was absolute value. So I don't want to get too technical on you here, but if you put that in absolute value, you would still get what? What's the absolute value of negative 30? It's just 30. So what I'm trying to show you is this. There's a lot of chatting going on. It needs to stop. So everybody listen. So what I'm trying to show you is this, that it doesn't matter the order that you subtract these two things in. All right, as long as you make it positive at the end, because we're looking for distance, how far something is, the length of something. I don't care about it being negative or positive, so we forget the negative. It just comes out to 30, so either way you do this. Everybody understand that? So that's like going left and right. You can do the same thing like going up and down. So let's say you're looking at a map. Oops, let's try this again, like that. Use different numbers. I mean, this is really no different at all. Let's say you're starting at the 10-mile marker and you have to go to the, I don't know, let's make it easy, 15-mile marker. All right? And you want to find out how far do you have to go from the 10 to the 15. That's easy. Again, it's not a trick question. It's just very simple. I'm trying to work you up to it. So what do we do here? What's the math? What's the math involved, though? Subtraction, right. So we go 15 minus 10. Now you could go 15 minus 10, which is 5, or you could subtract the other direction. It doesn't matter which direction you subtract. You could go 10 minus 15. But what's 10 minus 15? It's negative 5. But if we take the absolute value of it, we still get 5, okay? So again, I don't care about the negative. I just care about the length of this thing. 15 minus 10 or 10 minus 15 doesn't make any difference as long as you just consider the positive part of this. All right? Now, I know this seems pretty easy right now. Let's ease up with the candy or I'll make you throw it out, okay? So watch. It looks pretty easy right now, but I'm working up to something here. So we went horizontally and we went vertically. So what we're going to do is do a combination of those right now. Let's make this a different color. Let's make it yellow. So let's just, tell you what, let's label some points here. 1, 2, 3, 4. 1, 2, 3, 4. So I'm going to make a little X and Y axis right here. X axis, Y axis, and put a couple points here. I don't know. Let's just say right here, and let's go, we'll go like way up here. I'll tell you what, let's not get, just trying to get different numbers here. Let's go right here. Okay? And I'm going to connect the dots. I've got a line segment. What I want to do is I want to find out how long that line segment actually is. So it's not just as easy as just counting over, just doing one simple subtraction problem, is it? Okay? It's a little bit different. What I'm going to do is I'm going to label these points. This point right here, what do you think this is called? Negative 2, and then 1, 2, 3, 4, negative 4. So negative 2, negative 4. This point right here, 1, 2, 3, 1. So that would be 3, 1. All right, John, you writing all this down? Okay, don't worry about that. Come on, write this down. Yeah, there is. There's a graph right there. I put 2 points there. I labeled the points. So there is something to write down. So write it down. How can you tell me there's nothing to write down? That just blows me away that you would say something like that. It's just because it's ridiculous. Why? It's the only thing I can do is laugh when you say there's nothing to write down. Look at all this stuff. You kidding me? I'll write it then. So watch what we're going to do. I'm just going to teach, okay? If you don't want to pay attention, I'm going to try not to worry about it. That bugs snot out of me. See people not paying attention, but I'm just going to try to teach. And that's your problem if you don't pay attention. So watch. What we're going to do is this. I can't really just count, say 1, 2, 3, 4, because the grid marks don't go diagonally like this, but the grid marks do go up and down and across. So what I'm going to do is this. I'm going to find out how far up and down to get from this point to this point. Pretend it's like a city block in New York. Okay, you can only go by blocks. You can't go diagonally across the street, or across the blocks. So let's say you're going to go straight down this way and straight across this way. Okay, that's one way to get from one point to the other. So let's go down about right there, and let's go across. I'll have to pop that up just a little bit, about right there. Okay. So there's a couple ways to do this. You could just sit here and just count how many down, because now you're going up and down, and you can count along this y-axis. That's pretty easy, because what was the highest point? That was 1, wasn't it? And how far down did it go? It went down to negative 4. So you could start here, and let's just count. 1, 2, 3, 4, 5. So the length of that is 5. But what if your numbers weren't this easy? What if they weren't real small where you could just count? What if this number, what if this number is way up here, like at 478, and this number down here was at like at negative 143? All right, that would be crazy to draw a graph and put 500 and something and 100 and something and try to count all the way down, wouldn't it? That would be ridiculous. So instead of taking this graph and counting it, what did we actually do? How did I find the length of that line right there? Well, what's this top number? It's 1. What's this bottom number? Negative 4. So what did we talk about before? How do we get from one point to the other? Think of them as mile markers. Think of this as mile marker 1 and this is mile marker negative 4. How do we find the distance if we know the 2 mile markers? What do we do? We subtracted, that's right. Okay, so we subtract. And remember, it doesn't matter what order you subtract in. Okay? We just make it positive at the end because I'm just trying to find out how long that little line segment is. So it doesn't matter what order we subtract. I'm just going to go 1 minus negative 4. Now be careful with this. It's not just 1 minus 4, it's 1 minus what? Negative 4. Let's figure out what that is. Add a line, change a sign. What is that? It's 5, just like we counted, isn't it? All right? But remember, if these were real big numbers, you wouldn't sit there and count on a graph paper. That would be kind of ridiculous. So we got to figure out a better way to just than graphing it and counting. So I take the top number, subtract it from the bottom number, and I got that length right there. And you're probably thinking, well, who cares that I know that length? I thought I was trying to find the yellow length. Well, it's going to help us out, and I'm going to show you here in a second. Let's do this one. Let's find that length right there. Again, we could count. So how far over are we at this point? We're at negative 2 here, aren't we? How far did we go over? Well, we went over to the number 3, but you're right. Let's count. 1, 2, 3, 4, what? 5. So we went over 5. But again, let's not just rely on us counting over on a graph. Let's think of what we can do. What did I do with this number and this number to find that whole length right there? I subtract, that's right. And you could subtract in any order. You could go negative 2 minus 3. But what would you get with negative 2 minus 3? It's negative 5. Add a line, change a sign, right? They're both the same sign, so you add them up, keep the sign. But remember, we don't have a negative length or a negative distance, so what do we do with this? Just make it what? Make it positive, that's right. So look what I have. I've got this side is 5 and this side is 5. But again, I'm going to ask you the same question. What's the big deal with that? How does that help us find this yellow distance right here? Do you see what we drew? I'll give you a hint. Do you see what kind of a picture we drew? What is this thing right here? It's a triangle, isn't it? What did you learn in Algebra 1? And it's not just any old triangle, it's a right triangle. What did you learn back in Algebra 1? Watch this. I'll try to make this kind of accurate. So that kind of, I just took it out of all the graph stuff, right? So it's a little bit cleaner. This was 5. This was 5. This is a right angle. And we're trying to find this. We'll call it D for distance. What did we learn in Algebra 1? Maybe even before Algebra 1. Say it. Very good. That's it. It's Pythagorean Theorem. Do you remember that? Pythagorean. O-R-E-A-N. Where in the world did that word come from? Just some made-up word? It's actually named after a guy. One of those dudes with one name. You know how these guys way back in the day seemed like they'd walk around with robes and stuff, and I don't know, that's the way I picture them. Like Plato and Aristotle. Remember those guys? And they just have one word names, okay? Well, the same thing with this guy. This guy's name was Pythagoras. Anybody remember hearing about Pythagoras? Pretty interesting character. He did a lot of things. This is not the only thing he ever did was this theorem. He did a bunch of other stuff. He was a philosopher, a mathematician, a scientist. He was kind of a religious, you know, he talked about philosophy and religion and things like that. So this is not the only thing he did, but this is what he's probably most known for, is this thing right here. And I don't even think he came up with this. He actually just came up with a nice proof. Don't worry about what a proof is right now. We'll talk about that later. But he actually came up with a proof for this theorem. People knew this theorem already, but he's the one that wrote it all out nice and pretty, published it, and people said, oh, that's why that works. So that's why they named it after that guy, Pythagoras. So they call it the Pythagorean Theorem. What did the Pythagorean Theorem say? That's it. It was a squared plus b squared equals c squared. Now the a represented one of the sides, and the B represented one of the sides of a right triangle. And the C, what fancy math word did you learn what this one it was? Circumference is around a circle. What's this? Starts with an H. Give you a hint. What is it? Hypotenuse. That's right. You said it. Okay, hypotenuse. All right, so this represents the hypotenuse. Now I made it D instead of C. Why in the world did I make it D? Just to confuse you? No, because D is representing what here? It's the distance. That's right. Okay, so D represents the distance. Does this ring any bells to you? Remember this? Okay, a squared plus b squared equals c squared. Yeah, it's something you probably learned before this. And we actually will have a whole chapter, a whole entire chapter, not just on triangles, but just on right triangles. A whole chapter just on right triangles. And one of the main things we're going to be talking about in there is the Pythagorean Theorem. All right? But it is something that you probably knew before. So what I want to show you is this. How in the world could we solve for d? Well, let's put these numbers in. I wish I would have used something that had different numbers, but that's okay. So what is it? The a would be 5, so it's 5 squared plus what? 5 squared equals, in this case, instead of c, what did I call it? D. So call it d squared. So let's work this out. 5 squared is, yep, it will be 50, but let's do it one step at a time. And that's d squared. So 25 and 25 is 50 equals what? D squared. Is that the distance? Is the distance actually equal to 50? No. You got to get rid of that square, don't you? Do you remember how to get rid of a square? Square root it. Very good. You take the square root of both sides. And so d is equal to the square root of 50. Now, for right now, I'm okay if you just leave your answer just like that. I'm perfectly fine with that. All right? If you want to put that into a calculator and get something, you can. It's probably like around 7.1 or something. Who's got a calculator on them real quick? Calvin's that a calculator right there? Underneath your papers? Punch this in real quick. Come on. It's probably 7.1 is my guess, or 7.0 something. Square root of 50. Do you know how to do square root on there? 7.7? 07, right. I was going to say. Yeah, 7.07, which is about 7.1, isn't it? All right, but that's an approximation. This right here is an exact answer. This right here is an approximation. I would rather you have the exact answer, square root of 50. But if you write 7.1, that's fine too. I'll take that. So you're probably saying, how in the world does this have anything to do with what we're going to do? Well, I'll show you. Watch this. We're going to actually make a formula out of this thing. Let's go back to this. Let's go back to this. Now look at right here. You know what? Let's go back here. Sorry. Trying to figure out the best way to arrange this thing. What if I give you 2 points, but I don't tell you actually what those points are? We'll call that x1 and y1, and we'll call this x2 and y2. All right? This could represent any numbers at all. Would you agree? So it's 2 points, and what I want to do is I want to find the distance between those 2 points. So here's what we're going to do. We're going to do Pythagorean Theorem, basically. All right, let's think about this. Oops, sorry. Oh my goodness. What's going on? There we go. So watch. Let's call this one x1, y1, and let's call this one x2, y2. And what I want to do is I want to find the distance between these. So what did we do on that other problem? We went down like this, didn't we? And then we went across like this. But I don't want to have to do that every single time. I want just one nice little formula that I can just plug numbers into, and I don't have to draw stuff out. I don't have to draw a right triangle. I don't have to count down and count over and all that kind of stuff. I want to stick it in one formula, and this is exactly what we're going to do. First thing we do is we got to find the length of this. This is the y. So how did we find the lengths of the y's? We subtracted. We went y1 minus y2. Then how did we find the lengths of the x's? Well, we subtracted the x's. That's x1 minus x2. So this is one side, this is another side, and this is our d. So then I took this distance and this distance, I squared them, added them up. I put them into Pythagorean Theorem. So watch. Let's do d first. Let's put it, instead of a squared plus b squared equals c squared, let's do the c first, which is d squared equals, watch this. Let's take the x1 minus x2. That's the distance across, right? This is kind of like our a. And this is y1 minus y2. It's kind of like our b. And that's basically right there our distance formula. It's really just taken from the Pythagorean Theorem. So the distance formula is not just some crazy formula that people just kind of guessed at. It was taken from the Pythagorean Theorem. And this is it right here. Now, you're going to see it written in the book because this is d squared equals this stuff. In the book, you'll see this. How did we get rid of that squared? We did that earlier. Took the square root. So this is what it's going to look like in the book. It's going to be a big old square root, and then this is how I always write it. Doesn't that look like Pythagorean Theorem? Because it's a squared plus b squared, right, equals c squared. So what goes in here? Just subtract the x's. Now, does it matter what order we subtract them in? Now, remember we said earlier, to find the distance between 2 points, it doesn't matter what order we subtract them in. So I could go x2 minus x1, or x1 minus x2. Doesn't make any difference. Same thing with this. And right there, that's what you'll see in the book, that formula right there. Either one of those is the same thing. You understand that? How did I get from here to here? I just took the square root of both sides, that's all. But they're both exactly the same exact formula. All right? That's something you have to know. You got to memorize. Now, do you have to know how to go through all that stuff that we did earlier? No. But I think that was good for us to see how they came up with this formula. I could have just sat there at the beginning of class and said, okay, here's the distance formula. Just plug the numbers in. Boom, you're done. I don't think you would have had the appreciation that you need to have of it if we would have just done that. So here's the big question. A lot of you guys are going to say, well, how do I use it? So let's do one. Let's just make up a number. I don't even have the book in front of me. So let's go, I don't know, -3, -1. And let's try another point. 5, -2. All right? Just making up points. And what we want to do is we want to find, actually, let's put that up here. Find the what? What are they asking for? The distance. Right. Find the distance between these 2 points. This is the kind of question that they're going to ask you. I hope you guys are writing this down. A lot of people don't even have a pencil in your hand. You should be writing this down. Find the distance between these 2 points. So this is what we're going to use. We're going to use this distance formula. Right? Look at the 2 points. This is the x and this is the y. Do you see that? And this is the x and this is the y. So watch what we do. Distance equals big old square root. All right? Put a parentheses and another parentheses. Square them both. Put a plus in the middle. All right? Writing all this down, Joe? You haven't written down one thing I've written today, have you? Look at this. How do we figure out what goes in here? The length along the horizontal. We just subtract the x's from each other. So which ones are the x's here? The -3 and the 5. The first ones, right. Okay, it's -3 and 5. What do we do with them? We subtract. All right, let's do the y's. Let's take the 2 y's and subtract them. It's -1. It's not -2. What is it? Minus -2. And then we just do the math. -3 minus 5 is, add a line, change the sign. What is it? It's -8. But remember, you can look at it 2 ways. If I square -8, I get a positive 64. Or I could just make it a positive 8. Remember I said, doesn't matter what the sign, or, you know, if it comes out negative, we just make it positive. So really, let's just do that. It's 8 squared. What's this going to come to be? Add a line, change the sign. That's a positive 1 squared. Everybody see that? It's all under one big square root. I just took this, figured out it was 8, took this, figured out it was 1. I'm almost done. Keep the square root there. 8 squared. What's 8 squared? 64. It's 8 times 8. Plus 1 squared is 1. And then we are finished. Look at that. Add them up. Keep it under the square root. It's the square root of 65. So when they say find the distance between these 2 points, that's what it is. You could put this into a calculator. Calvin, give me that in a calculator. Square root of 65. It's probably like 7 point something big, right? 7.9 or something like that. What is it? Oh, sorry, 64, right. It would be small 8s, right. So 8.06 or about 8.1. All right, I'm going to tell you. It's 1 through 12. It's a worksheet. It's section 1-3. All right, you're only doing 1 through 12. There's more than that on the worksheet, but you're stopping at number 12. And I'll give it to you as you walk out the door.